as soon as the fan goes off, I know it has failed. I just don't necessarily know why. I did press the key on here I think I wasn't supposed to press. I realized right after. In any case, there's one pedal which is drawn between pi over 6 and pi over 2. And if you figure out its area, the total area of the whole thing is just 3 times that, because there's 3 pedals. And it's the same as integrating the sine. The span is in fact 2 pi over 3 divided by 2 again, which is pi over 3. That's the width of it. So it would be the same thing as integrating r equals 4 sine of 3 theta from 0 to pi over 3. The area within that. It just sort of makes it a little simpler to conceptualize. It's the same pedal one way or the other. All that happens when you go from sine to cosine is you rotate by 90 degrees. The pedal off of the sine would look like this and would come back in and hit at 60 degrees. This is a little easier to think about. Either way, it did not say on there what the formula is. See, for a polar integral. Now, of course, the way I'm thinking it is for any given value of theta, I have r as a function of theta, and I'm adding up these little slices, which are little triangles. So I should be adding up little triangles that have a height of r and a base of r d theta. So I should be adding up bits of 1/2 r times r d theta. That would give you the area of a little triangle. So if I zoom in on that line I drew there, I figure this is pedal, and imagine I have a d theta here. This area is the little dA that we're adding up, which is a triangle. And so a triangle, and the height of it is r. The base of it is r d theta. So 1/2 r times r d theta integrated, in this case, from 0 to pi over 3 times 3 for the 3 pedals. And then replace the r with what we know it is, which is sine, 4 sine. So I'll put the 1/2 out front. And then r squared, that's r times r is r squared, 0 to pi over 3, and then 4 sine of 3 theta d theta, that's squared. So up front, 3 over 2 times 4 squared is 16. Reduces to 3 times 8 is 24. So 24 out front for all the coefficients. 0 to pi over 3 of sine squared of 3 theta d theta. And then we just have to know how to integrate a sine squared, which we know that sine squared of x is 1/2 times 1 minus cosine of 2x.
You keep looking at my notes if I notice this. This is not my class.
You learned it more recently than me. You just took this class. Well, it was a little
I just took this class?
It feels like you just took it.
It's like
Time is moving
almost 2
differently
years
for me.
ago, about a year and a half.
Time is moving at a much more rapid pace in my mind. I was going to check that identity. I think it's right. Identity or sine squared. I've clicked on this site a lot of times before, so this must be the right place. 1/2 1 minus cosine 2. Yeah. Therefore, when you put the 3 in there, I'll get that sine squared of 3 theta is 1/2 times 1 minus cosine of 6 theta. Okay. stretch, unless of course I messed up with that initial plan. I think the triangle thing works, but I suspect it might not be the way it was actually taught in your class. I might have given you a Jacobian.
She doesn't know anything about Jacobian. I asked her, so I don't think so.
Well, okay. And there's another 1/2. Pop that out there. And we're going to integrate 1 minus cosine of 6 theta d theta. So 12 times. Integrate the 1, you get a theta. Integrate cosine. You get sine. Minus sine 6 theta. Chain the 6. That's not really a chain, is it? That would be a derivative. But anyway, that works. You can do a substitution there if you wanted. And then we just plug in. So when the 0 goes in there, we get a 0. When we put the 0 into the sign, we get a 0. So the 0 plug-in is just going to give us nothing. So we have 12 times pi over 3 minus sine of 6 sine of 2 pi over 6. Well, that goes away too. So all we're left with is 4 pi. And I hope that's the right answer. If that's not the right answer, then that's because this was wrong. If you had not done it one pedal at a time, you would have had to be careful about the fact that R goes negative. At least we got a positive answer, and that's a 50-50 proof that it was a good go. Because if it came out negative, that would be bad. Alright, now what's supposed to happen is I come back here to my recorder, and I hit save record.